just about sailing, December 2019, very beginning of December this one, so there'll probably be another one out this month. This one is all, last video was all about the theory behind where I want to put the heated air inlet and why for the Chinese diesel heater that I've installed, and in particular how that affects condensation. So this one is all about the practice, because as you know, that famous old saying that in theory and practice are the same, but in practice they're different. So this is all about the practice. So all this video will be is two experiments. One where I've set up the inlet so that the air is recirculated within the cabin, and the other one where the air comes from the outside of the cabin. Measure various things and look to see which is best for condensation, and also, to be fair, to see which is the best in terms of power consumption and so on, both in terms of amps and fuel, because obviously if you're taking and recirculating the air within the cabin, you're heating warm air, so it's going to be less energy taken up. Before I start, there were three things I did want to try and get sorted out with the heater before I did this experiment, of which I've managed to do one of them. We'll talk about that in a second. One of the things I want to do is, because of condensation in the exhaust, I wanted to fit a water trap, but it's only arrived today. It's one of those, so that will be fitted. So I've done this without the water trap. Basically that goes at the lowest point in the exhaust. You fill this up with water, and the idea is the exhaust can go through, but water can drip out without letting the gas out. I'm convinced that this will work, but when I put it on, I shall probably put the carbon monoxide alarm very, very close to it and run it and just check that it does work. But there's no reason why it shouldn't work. So that will be fitted very soon. The other thing I wanted to do was to fit a 10-litre tank for the diesel, but I couldn't do that for the reason I need to move a few things around in the locker. Actually, let's have a quick look at that. Right, this is inside the locker, and as you can see, this is the bilge pump here. And to operate the bilge pump, the manual bilge pump, you actually have to open the locker lid, which is no good. And also, just here, that's my fuel filter. I want to at the very least swap those two things round and then put the 10-gallon tank sort of underneath about where the fuel filter is. So I'm currently still using the 5-litre one, and I will swap that out, but I want to figure out how to do all this stuff first, so that's going to be a job that's just going to have to wait. So yeah, so at the moment I've still got the 5-litre tank, but that will be sorted out. And the other thing that I wanted to do was, and a few people have talked about this, is to put more lagging around the conduit, the pipe that actually takes the air into the cabin. So let's have a look at that. I've done that. This is the hose, I think it's 75mm diameter, that goes from the heater to the cabin, and it's quite long. It's, you can't even get the whole thing in shot. That must be about 4.5 feet long or something, a metre and a bit, whatever, but long enough. And I have put some lagging around it, and I was slightly surprised, which means disappointed, that the lagging didn't cool it down as much as I wanted. So I'm losing some heat through there because I want as much heat as possible to come out the thing. So what I'm going to do is I'm going to put some of this tape, which is specifically for this type of purpose, around this. This is kind of an aluminium reflective foil with kind of bubble wrap in the middle. You've seen this sort of thing. I did take a measurement before, and I might see if I can remember, I'll replicate that. So I think that will help more hot air come out. So I'm going to do that and do a little bit of prep work, and then we'll get on and do the experiments. Right, so it's getting quite close to the temperature that I set it for, so I'm going to just take some measurements. 50s, 60s, if I can shine it right inside 61. 61 degrees C coming out there. Right, so this is an important consideration. How well is this lagging working? So 29. That's higher than I would have expected. Right, so I'm hoping I can wrap this around here and then still get this back on over the outside. Theoretically, I think I should be all right. Right, so I think this is going to work. I've just done the first sort of half foot or so. Put some silver aluminium foil around it just to hold it still, and it's a bit snugger, but I think with patience, yeah, I will be able to get this on. So hopefully this will make a difference. As I say, it'd be really nice. I shall compare it with what the temperature was before. And that's now showing 26.4. I don't know if you can see that. The screen was not going out right yet. Well, but 26.4, very happy with that. And that's in the 80s. Yeah. So that was well worth putting that lagging around that pipe, well worth it, because obviously the more air I can get, yeah, that's hot. You wouldn't want to put your hand too close to that. Excellent. So it's well worth doing the lagging there. So let's look at the experiments. Basically, 2 experiments. Each one is 3 hours long. To make it realistic in terms of how much moisture I'm putting into the air, I'm going to have 3 cups of tea, which means boiling the kettle, obviously water vapour coming out, and make some food, and I'm going to make an omelette. It's also a chance to use the Origo stove. And throughout I'm going to check the internal, the inside, the outside temperature, the relative humidity, check for condensation, and very importantly measure the hull temperature, because if the hull temperature goes below the dew point, then I'm going to get condensation. So anyway, let's just start the first experiment at the point where I've turned the heater on. It's gone up to the operating temperature that I've set on the thermostat. So I set the thermostat for 22, and it kind of ramps up very quickly, and then it gets a steady state, and then if it drops down too much it will ramp up again, etc. So let's join the first experiment at about 33 minutes in, which is the point at which it's ramped up to that temperature. Right, for experiment 1, you can see this is the companionway and the steps. That is the air outlet, which I fitted permanently, so that's staying there. And temporarily, just for experiment 1, that, if you can see that, that is the inlet just under the stairs. And the reason I put it there is simply because there was already an inspection hatch there, or somewhere where I could fire the fire extinguisher through if the engine ever caught fire. So possibly not ideal, but the air blows out of here quite solidly, so I think this is a fair comparison. If experiment 1 does prove to be the most successful one, which I'm not expecting, I wouldn't put it there. I would do something and mount it, I don't know, higher up somewhere. But anyway, so this is it. That's the setup for experiment 1. So what I said, and what I'm going to do for the next one as well, is having got to this point of view, I'm going to have a cup of tea. Now obviously, one of the things that's going to do is to put some humidity into the boat. And it's feeling really pleasant in here actually. This is extremely nice. So let's wait for that. So I've just realised I'm kind of cutting my head off completely. There we are, that's better, isn't it? Right, so a nice cup of tea, which is very, very important. And at this point I could go through the whole, how to make the proper cup of tea, but
it's not everyone who can make a good cup of tea. It's simple, really, but many people get careless about tea making. Careless? They don't know the secret, you mean? There is no secret, really. That's a fallacy. Just a few simple rules to remember.
You know what those steps are. Goodness gracious me, if you've watched this channel long enough, you'll certainly know how to make a nice cup of tea. Right. Well, quite impressed with the Origo. It's really easy to control actually. That was about, I didn't time it, but I think it was about 10 minutes to boil that up, probably a little bit slower than gas. It doesn't smell as much as gas, but yeah, very happy with that. Right, so it's been ticking over for about 3/4 of an hour now, where there's just a tiny bit of, and I don't even know if you can hear that, it's very, very gentle, warm air. I'm putting my hand down by the heater now, and that's it's quite a pleasant temperature rather than the hot. So 3/4 of an hour, and it's still only drawing half an amp current. I'm going to make myself an omelette. I can find out how hot my omelette is. That's 91.8 degrees centigrade. I think that's pretty good for an omelette. I never thought you could use one of these for cooking, but that's well, there you go. I have to say, very happy with this Origo for cooking. You can probably hear it sizzling in the background. That's cooking an omelette, and it's it's perfect. Right, so this is literally the perfect omelette, and I'm going to put another cup of tea on because I want to have. Can you see that? But yeah, very happy with the Origo stove. A lot of people are very enthusiastic about them. And I can understand why. It's so easy to use. I'm pleased I got rid of gas. I don't like having gas on the boat. So the relative humidity has gone up. Oh, the kettle's boiling. There we go. Right, sorry about that. Obviously the so the relative humidity has gone up, and it's about 75 at 21.3 at the moment, so the temperature hasn't changed enormously, which is in a way not surprised, because obviously I've done some cooking and made another cup of tea. Let me just take a whole temperature and see what that's at. So that's 15.7, which, as we know, is, I believe that, I'll do the calculations, but I believe that's under the dew point, so we should get condensation. And if you can see this, I don't know. Yes, there is condensation, there is water on there. On here, that's 18.5, 18.6, which I think is above the dew point. And that is dry. On the fiberglass walls at 17.6. That is dry. That's just about sort of on the dew point. So interesting. Perhaps this physics stuff actually works. So it's kind of typical, isn't it? Sitting here for ages, nothing going on. As soon as I make myself something to eat, all the interesting science stuff happens. My omelette is still warm. Well, it's 27 degrees warm. That'll do. Right, it's 3 hours in and I've decided to call it a day at that point. Apart from anything else, that number of cups of tea, you know, when you're younger, your head rules your heart, then when you get older, your heart rules your head. But seriously, and I think the demographic of this channel understands this, when you get to my age, your bladder rules everything. So yeah, that seemed to be just levelling off and staying where it was at after it first heated up and then kept on ticking over. So the humidity was a bit too high, didn't go down. So let's wait and come back and do experiment 2. I've measured the fuel and stuff, and I'll do a little summation of how much in terms of ampage and diesel, etc. was used. So not a huge amount of surprises there. That's how I would have expected it to have gone. The relative humidity did stay up quite a lot, and the temperature stayed very steady. You know, it didn't. The heating didn't go back down again. So I'm very pleased about that. And I don't think that used up very much fuel. What was it? 0.43 of a litre, less than half a litre for 3 hours worth, and very little in terms of current that was used. There was some condensation, and that's simply because the window frames became lower, reached a lower temperature than the dew point. I was quite surprised to get condensation because the temperature outside wasn't particularly cold, 14 degrees. That's a decent summer's day in the UK. But the physics works, to the degree. As soon as the temperature of that wall goes down even slightly below the dew point, you get condensation. And it wouldn't take much of the temperature to go down for us to get significant condensation all over the walls. But in fact, in experiment 2, which we're going to go into in just a second, the temperature outside was a lot lower. It was about 8-9 degrees. And the temperature of the walls was a lot lower. But let's go into that now. Let's first have a look at where I put temporarily where I put the inlet. And then we'll go straight into the experiment, and we'll join again at the point where I've turned on the heater and it gets up to the running temperature and I'm just about to make a cup of tea. So let's join at that point. And this is the setup for experiment 2. That's the inspection hatch by the top of the rudder, and I've literally just bent it around there, taped it in place so that sort of if it rains, which it will, the rain can't get into it. So there we go. No, this is not permanent. But anyway, so this is the setup for experiment 2. So let's see if it makes a difference. Right, so we just got to the stage where the diesel heater has reached what I set it at, which was 23 degrees on the thermostat. It's about 22 degrees, which is perfect in the cabin. I am making myself a cup of tea, so I'm going to do exactly the same as I did before. Today is actually colder. It started off, the inside temperature was 10.6 degrees at 92% relative humidity. Currently, let's do this so you can see. Currently we're at 57% relative humidity and 22.1 degrees, so the relative humidity is lower already. It took a lot longer to get to this stage. It took 52 minutes as opposed to 33 minutes, but again, it is colder outside and I'm not recirculating the air. So oh, by the way, in terms of, because I showed what I've done outside, what I'm going to do when I actually get the air in is to have one of these devices on the hull, and then have some sort of a loop to stop the water getting in, and then this sort of shell thing goes on the outside. So that's how that's how I'm going to set it up when I do finally decide where I'm going to put it. And this is one of these Vita Sirocco things. So anyway, I shall have a cup of tea, and once I've had a cup of tea I shall make myself an omelette, and then once I've made myself an omelette I shall have another cup of tea, and then I shall see where the relative humidity gets to. I'm quite pleased at that, because that's 57 at the moment. Right, I think this is the same timing that I did with experiment 1. Omelette is now finished, so I'm just about to dish this up. And put the kettle on for a second cup of tea. So again, absolutely perfect omelette. Really pleased with this stove. The relative humidity has gone up to 62, by the way, and I think that when I was doing this before it went up higher than that. So the relative humidity has stayed down. So anyway, what I'll do, and it's still on tick over and the temperature is not dropping. I thought it would drop an awful lot quicker actually. What I'll do is when we get to a point, probably after I've made the next cup of tea or even the one after, let's see how high the relative humidity can go and work out what the dew point should be, and then measure the window frames and do exactly the same again. So right, I'm now going to enjoy my omelette. I do eat other things other than omelettes, by the way, but if you're doing an experiment, you've got to do it, make it fair, haven't you? Right, this did briefly go up to 62% relative humidity. I've worked out using the graph that the dew point at the hull for condensation, the dew point would be about 13 degrees. The window frame is about 14.5. So that's about the dew point. Indeed, we haven't got any condensation. The vinyl 16.8, that's well above, and the outside hull, the fiberglass, is 15.4-ish. Right, so we're coming to the end of experiment 2. I'm going to be switching everything off in a few minutes. Immediate observations is that the relative humidity, which is now at 60%, the maximum it went up to was 63 very briefly and then dropped straight down again. So it does seem to be easier to control the relative humidity. No condensation at all, despite the fact that the hull temperature, the window temperature, etc., got a lot lower. I'll do the maths and have a look at the graphs. So there we go. Whatever else, I got to eat 2 nice omelettes on my lovely brand new Origo stove. That's the first time I'd used it. I was very, very happy with it. Experiment 2, by the way, in terms of consumption, the ampage consumption was the same. It was about 3 amp hours. Not quite sure why that is, but the consumption is actually quite low, so I was happy with that. And the fuel consumption was 0.5 of a litre, half a litre, so a bit more, but I'm still happy with that. And the reason it was more, obviously, was that the air was colder outside, so the heater had more to do for longer to actually get the cabin temperature up to 22 degrees, as we will see in these 2 charts, which I will put up here. So the experiment 1, well, by the way, the green line at the bottom, that's the temperature outside the boat. The orange line in the middle, that's the relative humidity in percentage, which is the scale on the right, inside the boat. And the blue line at the top is the temperature in degrees centigrade inside the boat. That's the scale on the left. So what we can see here is, if we take point 1, first of all, in experiment 1, it took about 33 minutes to get up to that maximum of 22 degrees, which is what I'd set it for. And then after that, it stayed at a kind of a steady state. It just sort of, the heater ticked over, which I was slightly surprised at, but pleased, because that means less fuel consumption. What did surprise me was that on experiment 2, it did the same. It took longer to get there. It took 52 minutes to get to that 22 degrees. And then it stayed at a sort of a steady level throughout, that sort of tick over, which is probably why the fuel consumption wasn't fantastic, even though it was colder outside. If it had been much, much colder outside, I think it might have dropped a little bit, but who knows. I'll try this again. I probably won't do a video, but I'll mention it in the future. The key thing, though, the key difference was in terms of the relative humidity. What we can see in this experiment 1, I explained in the theory of part 1 why we can see this sort of crossover. We can see the relative humidity dropping significantly as the air heats up, and that's just to do with the way that relative humidity is calculated, and that was all covered in the first video. So we can see in experiment 1 that as I'm putting moisture into the air by making the cups of tea and so on, it's gradually going up. It got to a maximum of 75% and then went down a little bit, but then it started to creep up again, which is what I would have predicted because the air is being recycled. In experiment 2, it got down to quite a low level, below 60%, which I was very pleased with, and very, very pleased indeed. And that's because it's taking the colder but drier air in from the outside. Then as I was making cups of tea and so on, it rose gradually to a maximum, only very briefly, of 63%. And then it started to go down again as so it was actually getting the humidity, getting the water out of the air by bringing the new stuff in. This is exactly what I would have expected, exactly what I predicted. So what does that mean for the dew point? Because this is the key thing, because obviously we did find that there was condensation in the first experiment. So let's have a look at these 2 charts, which will be very familiar to you because this is what I covered in the first video. And we can see, and I did this using the maths and also using the charts, and to be quite honest, the charts are fantastically accurate. They're no more difficult to read than a tidal chart. They really aren't, and that's the way. So I'm going to get one of these laminated and keep it in the boat, because I was doing the calculations as we went. In experiment 1, we can see that at the points, and I've measured both of these, are at the maximum relative humidity, so the worst case in both instances, with a relative humidity of 75% at 21.3 degrees centigrade. That's the air in the boat. We're looking at experiment 1 up here. If I calculate the dew point comes out to, and this is based on the absolute humidity of the actual water in the air, comes out at 16 degrees centigrade. That means that if anything on the boat and inside the boat goes down below 16 degrees, you will get condensation, and obviously the most likely thing to go below that temperature is the outside of the boat, is the hull, is the the wall of the boat. And in this instance, the window frame did go just below 16 degrees, and yes, we got condensation. The bit with the vinyl on it and the actual fiberglass hull was slightly above that, so we didn't get condensation. So the physics works. Experiment 2, what we can see is that at 21.7 degrees centigrade inside the boat and at 63%, that makes a massive difference, because if we take that line along absolute humidity, we only have 12 grams per meter cubed in the boat, which means we've got a much lower dew point, so the temperature of the hull of the boat would have to get down to 13.1 for there to be any condensation, and it didn't get down to 13.1. It got, I think the window frames got down to a minimum of 14, and remember, it's a lot colder outside, so had I been recycling the air in experiment 2, if I'd have done the same as I did for experiment 1, there's a great chance that I would have got condensation, a lot more condensation inside, particularly on the window frames, absolutely, but also on the fiberglass hull, because that went down below 16 degrees a lot of the time. So, you know, the theory and the practice kind of met up here. For me, it's obviously up to you what you do in your boat. I'm not going to tell you what to do. But for me, it's absolutely abundantly clear that the best thing to do is to take the air in from the outside to help with condensation. What I haven't covered here is some of the things I did cover in the first video, which is how much insulation to put in. I am going to put some insulation in specifically for condensation. Obviously, the other thing that happens when you put in insulation is you get a slightly warmer boat, but to be quite honest, I'm very happy with the way the diesel heater works. So I hope that made sense. If it didn't make sense, have another look at video 1 again. This stuff is important, the physics works. I'm not surprised at all by it. I'm very happy with the diesel heater, very happy and slightly surprised at how little fuel it sipped. Very pleased at how quickly it got the temperature inside the boat up to speed, and very happy with my Origo stove. So there we go, that's it for this one at the very beginning of December. Hopefully there'll be another one out in December. Hopefully I will get a Christmas special out. Not 100% sure this year, but thanks for watching. Do comment below, and see you in the next video.